Welcome back, everybody. So we're going to continue forward with right triangles. But before we do that, I do want to recap what we talked about in the last couple of lessons last week on Thursday and Friday with Mrs. Sullivan. So what we talked about was when we have a right triangle and we have three sides, we have A, B, and C, where A and B are the legs and C is the hypotenuse. We know that this relationship exists, which is also called the Pythagorean theorem. The relationship is that the sum of the squares of the two legs is equal to the square of the hypotenuse. So in other words, a squared plus b squared equals c squared, where we know that a and b are the legs and c is the hypotenuse. I'm going to write HYP for short. We also talked about how the hypotenuse is always directly opposite of the 90-degree angle, or directly across. I like to draw an arrow from my right angle going directly out to show where my hypotenuse is. The other two sides, which are called the legs, can be interchanged for A and B. We can call either one A and either one B. It doesn't matter. It's up to you. That was how we can find a missing side of a right triangle given two of the sides. So if we know any two of the sides, we can always find the third using the Pythagorean theorem. Now, that's talking about the sides of the triangle. What about the angles of the triangle? So we've already got our right angle, but we also have, let me use a different color. We also have this angle where angle B is, and we also have the angle where angle A is. Well, earlier in the semester, we talked about what was called the triangle sum theorem. And what that told us was that all of the angles inside of a triangle, any triangle, not just a right triangle, but any triangle, the sum of the three angles are going to add up to 180 degrees. Now, in a right triangle, let's use this one for example. We have angle A, which is this blue angle over here. We have angle B, which is the purple angle down here at the bottom right. And we have angle C. Well, angle C is my right angle. So I know in a right triangle that I'm always going to have a 90-degree angle in my equation. I don't know what angle A is. I don't know what angle B is. But I know that angle C is going to be 90. And those are going to add up to 180 degrees. Now, if I look at this equation, I could simplify this, or I could start to solve it by getting rid of the 90. So if I subtract 90 from both sides, we will find that in all right triangles, the sum of the two acute angles, okay, and I know that these angles are acute because they're smaller than 90 degrees. The sum of those two will equal 180 minus 90, which is 90 degrees. So this is the conclusion that I can make about two angles in a right triangle that are not the right angle. So in other words, I have my right angle C. I have angle A and angle B are the other two angles, and I know that those two angles must add up to 90 degrees. Now, early in the semester, we had a vocabulary term that we used to call two angles that add up to 90. That word was called complementary. So in conclusion, and this is the first part of the lesson for today, the two acute angles in a right triangle will always be complementary. This only applies to right triangles because we have that 90-degree angle already taking one of the three angles. Let's look at an example. If I move forward, here's a right triangle where I'm given one of the two acute angles, but I don't know the other one. Now, there's two ways we can approach this problem. One way is using the triangle sum theorem, but that way will take longer. We could also use what we just talked about, but I'm going to show both ways this time. So if we use the triangle sum theorem, okay, let me label these angles. I'll call this one A, this one B, and this one C. Okay, if I use the triangle sum theorem, I know angle A plus angle B plus angle C is going to equal 180. Well, I don't know what angle A is, so I'm going to put X. I know angle B is 25, and I know angle C is 90, because that is my bracket in the corner that tells me it's 90 degrees. Now I can simplify the left side of the equation by combining like terms. Remember, if you have two numbers being added on the same side of the equal sign, you can combine like terms to simplify before you solve. If you have two numbers on opposite sides of the equal sign, that's when you'll use your inverse operations to move them to the other side. In this case, I have 25 and 90 are like terms, so I can combine those together. To get X plus 90 plus 25 is 115 equals 180. So now, like I just said, I have numbers on opposite sides of the equal sign, so I can subtract to move them together. So I will subtract 115 from both sides. And I will find that my angle, my missing angle, will be 180 minus 115, which is 65 degrees. Now, that took a lot of steps. I had to set up my equation, I had to simplify, and then I had to solve. However, we just said from the previous slide that the two acute angles in a right triangle are complementary. So if I look back at this problem, I could have just even ignored C. I know that angle A and angle B will add up to 90 degrees because this is a right triangle. So now I'm basically skipping a step. When I do this, I don't know what angle A is, so I'll call that X. And I know angle B is 25. So now I'm skipping a step and I can just solve for X by subtracting 25 from both sides. And I will get that X is equal to 65 degrees. So as you can see, using properties of right triangles, we can solve problems a little bit quicker when we're looking for missing angles. So now we have two different techniques. We know how to find missing side of a right triangle if we're given two of the sides using the Pythagorean theorem. We also know how to find a missing angle if we're given two of the angles in a right triangle using the triangle sum theorem. And from the triangle sum theorem, we can conclude that the acute angles in a right triangle are complementary. Now, what if we're only given one side, or what if we're only given an angle and we need to find a side? There's other techniques that we're going to use that we're going to be exploring for the rest of this week. Before we can do that, we need to understand how to find sides in relation to angles. So that's what I'm going to explain here. There's three types of sides in a right triangle, depending on which angle we are referencing, what our reference angle is. So the three sides are the hypotenuse, the opposite side, and the adjacent side. We will be using these three sides to look at different trigonometric ratios later on in the week. Now, the hypotenuse is the easy one because that one is always the same, no matter which angle you look at. And we've talked about that already as well. We know that the hypotenuse is always the side opposite of the 90-degree angles, opposite of the right angle. So if I look at the diagram here, I've got three sides and three angles. The 90-degree angle is the angle with the bracket in the corner, or the box. If I know that this is my right angle, my hypotenuse will always be directly across or opposite of that angle. So my hypotenuse will always be this side. Now, as for the other two sides, the opposite side and the adjacent side, they will change depending on which angle is our reference angle. So we've got two angles that can be the reference angle. We have angle A. Let me use a different color. We have angle A can be our reference angle, and we've got angle B can be our reference angle. So let's look at angle A first. If I'm looking at angle A, so I'm looking at this purple angle. The side that is opposite to this angle will be the side that is directly across. To clean this up, I will get rid of these marks that I used for the hypotenuse so that we can see clearly which side is the opposite side. If I look at angle A, to find the opposite side, I have to go directly across from that angle. In this case, I purposefully labeled that side with a lowercase a to show that that is the opposite side. So the opposite side would be directly across from the reference angle. So now what does that tell me for, well, let's write that down. So angle A's, the opposite side of angle A would be side A in this particular example. What about for angle B? If we look at this one right here, which side is directly across, and I always draw my arrow so I can see it clearly. The side that is directly across from B, angle B, would be side lowercase b. So that would be my opposite side if my reference angle was angle B. So as you can see, the opposite side can change depending on your reference angle. Now, what about the adjacent side? So we've talked about this word adjacent before when we talked about adjacent angles. Now we're talking about adjacent sides. Well, when we say the word adjacent, what we mean is that it's right next to something. That's what the word adjacent means. So what we're looking for is the side that is right next to the angle. In other words, it's the side that connects the angle that we're looking at to the right angle. So if I'm looking at angle A, my purple angle, which side is right next to A? Well, there's two of them. There's side B and there's side C. However, we already know that side C is the hypotenuse. Okay, the hypotenuse cannot be the opposite and the adjacent. It's going to be a different side. So that only leaves us with one other side, which is side B. And as you see, it's the side that connects our angle A with the right angle C. So the adjacent side for angle A, where that's our reference angle, would be side B. And the same thing goes if we look at side angle B. Well, angle B has two sides that are directly next to it. Side C, which we already said is the hypotenuse, and side A. If we look, side A is the side that connects angle B with our right angle. So our adjacent side for angle B would be side A. So the definition for adjacent side, we can describe this as the side directly next to the reference angle. So these three types of sides are going to be very important as we move forward in this unit. We have the hypotenuse, which will always be opposite of the right angle, directly across from the right angle. It will also always be the longest side. Then we have the opposite side and the adjacent side, which will change depending on your reference angle. You may notice that the opposite side of one of the angles is the adjacent side of the other angle, and vice versa. So that's a relationship that we will be using later on as well. Let's look at this example. We're going to use this triangle, and we're going to use the numbers and the lengths of each side to identify the hypotenuse, the opposite side, and the adjacent side for each of our reference angles, which are the two acute angles, angle A and angle B. Let's start with angle A. First of all, which one would be the hypotenuse? Well, if we look at our diagram, the hypotenuse is always directly across from the right angle. So I know that my hypotenuse will be 5. Now, we said that that's always true no matter what your reference angle is. So let's go ahead and go to angle B and say that the hypotenuse is going to be 5. The hypotenuse will never change. What about the opposite side and the adjacent side? Well, if I look at angle A as my reference angle, that means I'm looking at the angle up here. My opposite side will be the side directly across from that angle. I like to draw the arrows to see it clearly. Directly opposite of angle A would be angle or side with the side length 4. And that leaves one side left to be the adjacent side, and I can see that the side with the length 3 is directly next to my reference angle A. Now let's look at angle B. If I look at angle B as my reference angle, my hypotenuse still is going to be 5, and that's never going to change. My opposite side will be directly across from angle B, which in this case will be the side with the length of 3. And my adjacent side will be the side next to the angle, which is the side with the length 4. And once again, as we pointed out in the last example, the opposite side of one reference angle will be the adjacent side of the other reference angle, and vice versa. So we can see that these will switch out depending on the reference angle.